So without further ado, let's keep the momentum going. Let's please welcome to the stage John Jones, the new, right, just on board, new Chief Revenue Officer at CoreWeave, and Dave Salvatore, Director of Accelerated Computing Products at NVIDIA. They're going to talk about accelerating AI infrastructure and balancing responsible leadership and relentless innovation. Let's give them a warm round of applause. Come on up.
Okay, thank you for that introduction, Dave. Thank you for joining us.
Yeah, good to be here.
For everyone who got to eat lunch with Mike, if you didn't get to eat lunch with Mike, this is about the only time you'll see him without his security detail, so go get a selfie and ambush him on the way out. All right, so thank you for the introduction. Dave, that was kind of a quick one. Why don't you tell us a little bit about what you do?
Sure. So my team at NVIDIA, we work with our cloud providers and work very closely with CoreWeave on all things relating to bring the NVIDIA sort of technologies to the cloud and helping to raise awareness and make sure that customers and the market in general just really understands the full scope of our partnership, but also the full scope of the capabilities of the platform. There is a bit of a tendency to think of NVIDIA as, oh, those GPU guys, but the GPU really is just the beginning. CoreWeave and NVIDIA have a lot of what I'll call cultural simpatico. You know, Gene talked earlier about your 3 Ps, you know, being performance, partnership, and pace, right? And I may have gotten the order wrong, but those are the 3. We're very much wired the same way at NVIDIA. You know, at NVIDIA, we talk about speed of light, right? Which is how quickly can we move to make something happen. And we have done some great collaborations with CoreWeave and continue to do them. They're ongoing, of course, but particularly around things like some of the work you've done with your submissions to industry standard benchmarks like MLPerf is something I've been involved in myself, that you guys actually hold the record for the largest at-scale submission the benchmark's ever seen at over 11,600 GPUs. And along with that, you have the training performance record to go with it.
And at the end of that, CoreWeave has a pretty good track record of
phenomenal track record, yeah. No, I think CoreWeave is, again, it's the agility piece, that sort of that bias towards just go, 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 and being able to also work closely with our engineering teams. You know, we have reference designs we make available to our partners called MGX reference designs. And I believe CoreWeave doesn't quite use it one-to-one, but they do sort of take, or you do take a fair amount of what's in our reference designs. You take it, maybe tweak it a little bit for how you want to deploy it, and then you guys deploy, and that helps speed your time to market.
Yeah, and as part of that process, there's a lot of talk about GPUs and GPU availability, but it's not really a chip constraint alone or chip deployment alone, right? There's a lot of hard work at the software layer, at the interconnect layer. Building clusters of these things is very different than building a few of these things.
Very much.
Talk a little bit, and the software stack, of course, that NVIDIA built is world-class and is by far the market leader. Talk a little bit about the importance of software as part of these deployments.
Software plays a huge role. I mean, without the software to really unlock the full potential of the hardware is a glorified space heater, right? I mean, you really need software to be, A, performant, but it involves so much work with the ecosystem. As many of your audience members know, open source software is a hugely important component to driving AI innovation. Right? It's one of the things that allows developers to kind of share work with each other, be able to take that work, build upon that work, and sequentially drive innovation into the market, right? CoreWeave makes a lot of contributions into the open source world, as does NVIDIA. We contribute on models, on frameworks, on things like our Dynamo inference serving software, which is also open source. And we do a huge amount of work in terms of submissions we make into the Linux project, which ultimately get rolled into the main code base of it, to help enable accelerated computing. And then a number of our own libraries as well are also open source. So, you know, the software piece is just incredibly important. And because the early work on deep learning was done on NVIDIA products, if you go all the way back to AlexNet back in 2012, we saw that opportunity, and we already had something in place called CUDA, which had been in the market for about 5 or so years. And we were starting to do things with it around scientific simulation, you know, whether that's CFD, molecular dynamics, what have you. And it turned out GPUs are really good at that. In fact, GPUs are pretty much really good at anything that can be parallelized because it's a massively parallel machine, right? Alex comes along, builds AlexNet. It was done on our product. And then we saw an opportunity for CUDA. So then we started building more libraries to help support this notion of deep learning. Because, I mean, AI has been with us for decades, right? But the notion of deep learning, of building networks that have multiple layers and massive amounts of compute necessary to drive them, was simply infeasible in the past, right? GPUs made that possible. So we've been driving and innovating software really for over a dozen years to make AI and help it drive it forward, right? And then of course CoreWeave, is doing a lot of that as well through work you do certainly internally and some of your recent acquisitions as well. You guys are also building out a pretty robust software stack of your own.
A lot of the workloads that you talked about, simulation, rendering, are very high performance, classical high performance computing workloads. By the way, is anybody in here willing to self-identify as having HPC expertise? No? It just means you're all much younger than I am. 16 minutes. Okay, so once you get into up to and through the GPU and the software stack, we were talking in the back, you have a long history of benchmarking too, going way back. Maybe you can talk a little bit about the arc of the benchmarking progress as it relates to pre-AI and then post-AI, because ultimately AI clusters are just big supercomputers.
Yeah, I guess we just had a pickup in the volume there. That's fine. Lunch coma might be setting in, so this will help keep them awake. They are similar workloads. They both have parallelizable aspects, but AI in particular is just embarrassingly parallelizable, which is what makes it such a great fit for GPUs. But again, the benchmarking space of AI has been pretty crazy, I would say. It's been kind of Wild Westy for some time, which is why we're a member of what's called the ML Commons Consortium, which builds the ML Perf benchmarks, both for training and inference. And they build a number of other benchmarks as well, but the data center benchmarks is our primary area of focus at NVIDIA. And we have done very, very well on those benchmarks. And we try and bring out new versions of those benchmarks about every 6 months, which as industry consortium-driven benchmarks go, is a very fast pace. That said, we're trying to even make that pace faster because of the rate at which AI is evolving. And so this is an attempt, frankly, to kind of bring some order to chaos, to kind of say, let's build a benchmark where we have directly comparable results. So we can actually look at two systems and go, okay, they did the same work, who's better, right? And there are fairly stringent requirements around accuracy, around the ability that the models have to converge if you're training, as an example. And these are peer-reviewed benchmarks. So once the results are submitted, there's about a month-long period where every submitter, and a lot of these are competitors, can basically scrutinize everyone else's submission. And if they see something that they think might be questionable, they can raise a concern. And that concern has to be addressed before the benchmark results will see light of day. So what you're getting is results that have kind of had feet held to fire, if you will, that frankly are more meaningful and directly comparable. Right? That said, there are other benchmarking efforts underway. Most recently, SemiAnalysis did a thing called Inference Max. We did very well with that with our Blackwell architecture. Very pleased to see those results. And it speaks to the growing importance of inference. And Peter spoke to this a little bit earlier this morning about the growth of the scale and the demands of inference really just kind of on this incredible, basically exponential trajectory.
So you get to see most of the benchmarking work. I know our teams collaborate closely together on that. I'll ask you about that in a minute. But from that objective viewpoint, how's CoreWeave doing?
CoreWeave, again, does very well. I think because of the close collaboration we have on the engineering side, and because you guys are also very focused on making sure you get phenomenal performance from our technologies, the result comes out in places like ML Perf. And you also, of course, on the recent Cluster Max evaluation that SA did, you guys also were the only submitter, I think, who achieved, I guess they call it the platinum level, which is the highest level. So no, CoreWeave has definitely proven itself. I mean, track record matters, right? And it's one thing to sort of basically do some kind of a performance stunt and go, look at how fast we are on this one model in this one condition. It can be a valid data point, but we all know that AI, particularly on the inference side, has so many parametric knobs that can be played with. That getting to directly comparable performance can be a real challenge, right? Whereas when you're willing to basically be weighed and measured in a place like, say, ML Perf, where you're going to be scrutinized if you do anything that's at all odd-looking, it means that the results that ultimately come out of that, frankly, are more meaningful. They're more credible, and I think they're ultimately a better guide to make informed investment decisions about where you want to build out your infrastructure.
And again, we were talking in the back, but pretty consistently, CoreWeave's shown that the company has the expertise and the engineering collaboration is showing up in those benchmarks, and pretty consistently, CoreWeave's coming out on top.
Yeah, no, CoreWeave has done very well with those. And again, I think that's a testament to the partnership, and it's also a testament to the level of engineering skill that Peter and his team have. I mean, they do terrific work.
Okay, all right, great. Well, let's move a little bit past the technical conversation. There are a lot of leaders in the room thinking about some of the hard decisions they have to make as it relates to AI, as it relates to infrastructure. I know one of the things you wanted to talk about is mental models around leaders making decisions about the future and how that impacts their business. Maybe you can share a little bit with the crowd here on how they should think about some of those decisions.
Yeah, it's an interesting time because agentic AI is getting going now, and we've seen some of the initial things that agentic AI can do for us, right? But I'd say we're still very much in the early innings on agentic AI. So as you think about, I mean, and a lot of us are business leaders, AI is no different than any other technology or tool you consider for your business. And the first question you want to ask yourself is, what business problem am I going to solve with it? Right? In other words, what are your biggest pain points in your business? It could be as simple as our wait times are too long when people call our customer support, and we want to have intelligent agents who can handle 80% of our support calls because those calls can be handled by an agent. And then for those tougher calls that need to be maybe escalated, then maybe we turn that over to a human being who can help solve a more complex thing. But the agentic AI has shown that it's able to handle very complex tasks, whether that's coding, around, what is it? What do they call it? The last human final exam or something. There's a number of quality tests. There's a website called Artificial Analysis, some of you may have heard of, and they look at quality across there's a number of quality metrics in the agentic AI world, right? And they do an intelligence index, which sort of tries to bring them all together into one metric that's kind of useful when you want to look at different models and different endpoints. But really thinking about also roadmap. Right, it's important to think about that AI, working with AI is probably never, well, I won't say never, never is pretty strong.
It's a long time.
It's a long time. Let's just say it will be quite some time before AI will be a one and done kind of a thing that you're building because of the rate at which it is growing. Because like any technology, it can cut one of two ways. It can either be your competitive advantage, or if you want to go kind of more the FOMO side of things, it can leave you at a competitive disadvantage if you choose not to actually use it, right? And AI is, in a lot of ways, it is a game changer, not only for, as an example, support agents is one example, but amplifying human capability, which we actually saw earlier in the survey results. That ability to have your teams be able to do much, much more with these resources. In fact, my own team, we increasingly are using these resources to do things like market research, build out marketing plans, and do surveys of things like examples. A great example is what's going on in the world of AI research. It's a very, very hot area of research in computer science. There's a great website called archive.org, arxiv.org, which is hosted by Cornell University. And a lot of research papers get first published there. And so a lot of times I'll have my agents go and say, okay, I want you to scan archive and tell me over the last 2 weeks or a month or whatever, what are the 10 most interesting papers that have published there, is a way to try and keep a weather eye on what's coming, because again, the rate at which things are moving is extraordinary. And so the other, I think, thing to bear in mind there is, be thinking at least on I would say at least a 3-year horizon. And the good thing there, at least as it relates to, and how NVIDIA and CoreWeave work together, is we've already kind of shown you the roadmap in terms of what the platforms are going to look like in a couple of years. So you've already kind of got a hard data point there off which you can work. But think about, internally with your own companies, what are the business problems we're trying to solve? And another, perhaps harder question might be, do we have the in-house expertise to solve it? Because the answer will not always be yes. Some developers may be wonderfully capable developers. They might even be people who've worked with machine learning for many years. That doesn't mean they necessarily know how to work with deep learning, or more importantly, agentic AI. The good news is that one of the things agentic AI is very good at, of course, is coding, right? And so there's a lot of what's called now vibe coding, where you can basically speak what you want the application to do, and it will write a lot of the code for you. But that said, things are evolving very quickly. So it's important to really think about, where do we want our company to be in 3 to 5 years, and how can AI help get us there? So in other words, you kind of go outside in, which is, think about your business first and AI second. Because again, at the end of the day, you want the AI to serve you, not the other way around.
Okay, awesome. Who here is either building agents for production use or is using agents in production? The answer is for sure not zero. What are you using it for? In the back? Yeah. Okay. Yeah. Interesting. Anyone doing customer engagement work with agents? What are you using it for? CRM. Okay. Awesome. I like your data gathering. Thank you. I like your data gathering example on Intel. I used AI to ask, figure out what questions I should ask you, and we're recording, so I can't ask you any of them. Unfortunately, we have 7 minutes. Someone should move this back for Max's portion because he won't know when to stop, and he'll just keep going until the end of the. Okay. All right. So into agents. That's today. What's coming tomorrow? What use cases are you super excited about?
Well, like I said, I think we're still in the early innings with agents, and there's more being discovered all the time about intelligent ways to use them and how to deploy them. And there's going to be a little bit of learning curve associated with that. As an example, when you think about agentic inference, I'll just riff on that for a moment. A lot of the networks being built for that are what are called mixture of experts, or MOE networks, right? Which is actually a collection of networks that all work together as a team to help do more complex problem solving and actual reasoning, right? And it's those reasoning tokens that are kind of exploding the amount of compute that is needed for inference now. Because, I mean, essentially with generative AI and sort of the things that came before it, you basically had input tokens, output tokens, and a few processing tokens in the middle, and you got an answer, right? Reasoning tokens, many, many more tokens, perhaps orders of magnitude more tokens, depending on the use case, right? So there's that in terms of figuring out how to continue to evolve that, build it, and as the new models are coming out, the new community models continue to come out from model makers, they're going to bring more capabilities as well. And so there's also this aspect of, and again, this is not new for me in tech. I've been around tech for about 30 some odd years, is sort of the surprises. There's what we build and there's what we think it's going to get used for, and then sometimes there are the surprise use cases that are like, okay, we didn't think of that one. That's actually really cool. And then that can spawn a whole new sort of area of development. But the other piece, of course, when we think about autonomy with AI, right, will be things like physical AI, whether that's robotics, whether that's autonomous vehicles, autonomous devices that can help us with very repeatable, frankly mundane things that we would just as soon have some help with. We're going to see a lot of that intelligence that we're now working on in the data center. We're going to find ways to distill that and be able to deploy it in those edge devices to bring that agentic intelligence into edge devices. And there's a lot of work that has to happen there because obviously, you can't drag around a GB200 rack in a robot. That would be an awfully big robot. And the extension cord would be like this. So, but anyway, so I think physical AI is going to be another really interesting area as we see that evolve and its capabilities grow. And again, I think we're just beginning to get a peek at what Agentic can do for us. And I think you're going to see a lot more capability come to that sphere over the next year to 3 years.
Yeah. Okay, good. The Jensen slide in his keynote at GTC where he had physical AI up at the top right generated a lot of interest in what that was and in what that means. You've been at NVIDIA, so I'm going to ask you a question. I'm going to surprise you with a question. You've been at NVIDIA for 10 years?
But, yeah, almost 9 years. Yeah.
Almost 10 years. And then you talked about reasoning tokens, so I'm just going to ask you about this. So DeepSeek comes out, $600 billion in enterprise value disappears overnight. What was it like inside?
Not awesome. You kind of have to take these things with a grain of salt. As we all know, just on the financial side of things, tech stocks are kind of notoriously volatile. That's not a new thing. That's been going on for decades.
That would be an understatement.
Yeah. And we took it in stride. We said, look, first of all, in a lot of ways, we were like, okay, so seeing that much valuation vanish, again, not particularly enjoyable. But we also looked at the technology. And what we saw was that we believed, and the market ultimately kind of found its way back and kind of corrected itself, is that the market got it wrong. All the market saw was, hey, they just reduced the cost to train by to something seemingly trivial. What they didn't talk about was how much did it cost the DeepSeek sort of team to get there. It was years of work, billions of dollars of work to actually get to that technology. But the flip side is this, which is that efficiency means you can do more. Mm-hmm. Right? When you get one of those stair-step increases in efficiency, either through algorithmic innovation, architectural innovation, however it comes to you, you can use that benefit generally, broadly speaking, in one of two ways. You can either do more, or you can do what you're doing before with less infra and save money, right? And AI does not ever take a step back. So AI took that opportunity, that efficiency, and said, what else can we do with it? Let's drive it forward. And that's what we've since been seeing. And a lot of market analysts kind of came around and said, yeah, it turns out it's actually, it's not any kind of a threat, it's actually an opportunity to help, again, bring more innovation and enable more performance because of the efficiency that it brought.
Yeah, the unprecedented demand isn't just for GPUs; it's for AI capabilities. And
Correct, absolutely. Yeah.
That's a pretty big curve. Okay, we're getting close on time, so my last question for you will just be to talk about the partnership between CoreWeave and NVIDIA and what's to come, and why us working together, not just together, but with the broader ecosystem. Why you're so excited about that?
Well, what I'm excited about is, again, having been around tech for more than a minute. The things like our GB200 and GB300 architectures are fundamentally re-architecting server architecture as we know it, right? It used to be you had a CPU, which was kind of the center of the universe, and anything else in that server was hung off of a PCIe slot, right? I mean, everything else was a satellite basically to the CPU. And we realized years ago that as we made our way to continue to grow the capabilities of AI, that had to change, because the GPUs and the CPU need to be peer processors. They need to be able to talk to each other very, very fast. And also the GPUs, on an as-needed basis, need to be able to get in and out of CPU memory and do that over a very, very fast interconnect, which we built called C2C Link. What I'm excited about is as we carry that type of architecture forward, you know, the industry is just now kind of learning how to operate on that. Peter talked about this a little bit. How to operate on that kind of an architecture, how to scale on that architecture, right? And not just within, say, one NVL72 rack, but multiple NVL72 racks. And we're also working on things to be able to scale across data center sites, what we're calling gigascale, right? And so we're going to be bringing out another architecture, of course, next year called Vera Rubin, which we're very excited about. And Jensen's talked about this architecture kind of at high level of detail. But it's going to continue to drive compute capabilities forward, much more compute, much more memory, more improvements to NVLink, more improvements to NVSwitch. And of course, then we also are working like crazy on both InfiniBand, which of course CoreWeave makes great use of, as well as our Spectrum-X Ethernet switches. And so we continue to innovate in all these different areas. And the most exciting thing to see when we bring these technologies to market is, what does the market do with it? What are the things they do with it? Because like I talked about a minute ago, there's kind of what we think they'll do, and a fair amount of that comes to fruition. But then there's those couple of things that they do with it we're like, okay, that's actually really cool, and we need to go explore that. Right? So those are the things that I always love to see when a new technology comes out.
Awesome. Well, thank you, Dave, for joining us. Thank you for the partnership. Big round of applause for Dave and NVIDIA.